It's like orange. It's like the flight data recorder. And so if something bad happens in the plane, you gotta go to the flight data recorder. So black boxes I'm talking about are these little tiny packages. This is a black looking box. This is a black looking box. Even this is a black looking box. These little tiny things. On your starter projects, I think every single one involves an IC of some sort, right? Is that? There's any starter project that doesn't? Let's see. What were some of the startups? So Simon Says has a microcontroller in it. Mini POV has a microcontroller. The light color organ thing has two ICs in it. What else? What are the Minty Boost has an IC as well, right? What does IC stand for? Integrated circuit, yeah. So I got a mess of the circuit up on board with that. We'll into it, right? I'm going to pass around. Actually, I want you all to really crowd in. You all have to really crowd. You might have to stand for this. And
I don't care.
some of you, if you're behind, like, you get up close to the table, kneel. I like people to see. And these things are tiny. It's not like doing a chemistry demonstration where it's like, back up. These are not going to explode or anything like that. So this black box here is, it's called a relay. Anybody know what a relay is?
Electrical switch that you control like electrically.
An electrical switch that you control electrically. Yeah. So basically, the relay is an interesting device. I call it the seed of the information age because I'm going to take, we all know what this is, right? What is this?
It's another black box.
This? I hope you don't think it's a resistor. Robin just said after like 4 days, we would know, but maybe you need day 4 because, yeah. Okay, 9-volt battery. And again, I also said that these are nice because you can, these are on one side. Why did I say it's nice and convenient because they're on one side? Yeah, I can double check to make sure it's working at is because our tongue acts as what kind of device? A resistor, and we're completing a circuit, and the battery is then pushing current through our tongue, and that little tiny current actually feels tingly when it goes through your tongue. So, but I'm going to actually use this as my little tiny 9-volt, little delivery 9-volt, and you can hear, you listen very carefully. Can everybody hear this? Watch it not work. Can you hear that? You got it clicking? Okay, so I'm gonna, who can I ask to? How many pins are on there? 5 pins. So it's a black box with 5 pins sticking out. So there's 5 possibilities of like where things can go in and out. You guys are thinking about inputs and outputs. To make that click happen, I have this 9-volt battery with 2 leads coming off of it. So how many of the pins do you think I'm touching to make that happen? 2. Yeah, I touched 2 of them. And it clicks. There's other things I can start to mess around with, like probing a black box. So I can flip it around and it still makes noise when I touch it. Any idea what's going on inside of this?
Like a switch, the way this power switches into one state, or moves it, switch back to the other.
Yeah. And so inside this, there's a couple ways of going about like figuring out what's going on. I can like set up a series of experiments. I can be the scientist and like start probing each pin and applying voltage and other things and maybe even connecting it. What are these things?
LEDs.
LEDs. What does LED stand for?
Light emitting diode.
And when I test, whenever I hook up a light emitting diode, I can use another battery. Anybody use some of these batteries for the starter project? Yeah. About how many volts are these?
3.3.
3.3, something like that. And there's still a positive and negative side. And so I can actually use these to light an LED that's not lit up. Oh, my LED didn't light up. What should I check to make sure?
Polarity.
Polarity, yeah. So I'll flip it, and does it light up? Yeah, it does. And I can check the colors. This is a very
That's
handy
true.
way
I
to
thought it'd be
check
like
the
white.
colors. Say again?
I thought it'd be like white gray.
Well, you never know, and that's why having these with a bag of LEDs is always handy, because sometimes they're all clear, but they're all different colors, and so it's nice to check. Like, oh yeah, this is the red one. Because I have other clear ones here. I can even check which one is this. Oh, that's also red. I thought I had another one here. Are all these ones? Nope, there's a green one. Okay, so I can check it. And so I could maybe use little LEDs to figure out and set up experiments. Again, that's thinking like the scientist. Another way to figure out what's going on in here is, let's just cut off the top and see what's inside. And so, pass it around this way. And inside that, I'll describe it so we can be very efficient. There's a coil of wire. And when I apply this voltage to that coil, it turns that coil into something else. Any of you in elementary school take a coil of wire, put it on a nail, and stick it up to a battery? It's an electromagnet. Who made an electromagnet before? Raise your hand if you've made one. Nobody else did that in elementary school?
Well, not in
Really?
elementary school.
It used to be this like thing everybody did in elementary school. I guess because nobody brings. They pulled electricity and magnetism out of like the second grade curriculum or something like that. I don't know. But yeah, so that magnet inside, when we apply the battery, is activated, which then moves a switch. And so there's literally a switch track. So what's happening is we'll have the magnet pointing one way or off, and the switch might be closed one direction, and then when the magnet is activated, the switch moves to the other side. So there's a mechanical thing happening inside. The magnet has to physically move a lever. So this is what we call it an electromechanical device. And it was invented by this guy named Joseph Henry. He was a physicist at Princeton. I think he invented it in the 1830s. He never patented it, which is crazy, because later on somebody realized the battery and the relay, did they have to be in, like, does this battery need to be in the same room as that relay to make it work? This is where the engineering creativity came in. How could I change this? Like, if I want to make that switch, if I want to make this click, I'm putting this battery up close. There's my click. But I can make these wires longer, right? Where else could I could extend it out? I could be in that room next door, and I could still make that click. Does that get the gears thinking? Like, get the brain going, like, what else can I do with that? So what else could I do if I could be in a different place and still make that click? Nobody has any ideas?
Like,
Yeah, where else?
I guess you have to take a switch.
A switch, yeah.
Be a long distance switch.
Long distance switch, yeah. What could you use a long distance switch for? Why would you need it? I want to turn the light off in my friend's house. What else could we do?
Maybe like a doorbell or something, just like a
Doorbell.
hearing them, makes sense.
Yeah, and so what could you do if you could press a button and a buzzer rang somewhere else? Say that again? What did you
telegraph.
communicate? Oh, I'm shortening this out. I'm burning this up. And what did you say?
Telegraph.
Telegraph. Have you seen a telegraph before? Click, 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 Morse code and all of that. So yeah, that was the realization. That's the engineering step. It was a physics thing, an electromagnet, and then make a switch, and then let's put it to another use. So the guy who invented it invented the relay, didn't invent the telegraph. But he could have. I mean, the telegraph changed everything. And then people realized in the 1840s and 1850s, let's try to string a cable across the Atlantic. And the first one, it took like the 6 largest ships in the world at the time in the 1850s, and the guy who was leading that project, his name was William Thompson. Later we know him as Lord Kelvin. And it didn't work. Strung this cable across the Atlantic, and they tried to, and it didn't work. And they're like, is this actually possible? And then like 2 years later or something like that, they actually got one working. And once they got one working, all of a sudden there's cables across everywhere. Once people knew it was possible, then everybody did it. And so there's another thing, like, once somebody figures something out and creates a design based on somebody else's ideas, then other people can copy it. Because knowing is something is possible. And so in your projects too, you'll think, oh, I don't know if this is possible or not, but if you see somebody else get it done, you go, oh, okay, it's possible. Same idea with that story. Kind of tangential for black boxes, but yeah, it's a black box. and we can see what's inside, and hopefully you've all seen what's inside. Okay, we've talked about, we know what a resistor is, we know what a light emitting diode is, and the diode itself has a circuit component. What does a diode do? That's,
Directs current in one direction.
yeah, and the light emitting diode will,
It's like
when,
when,
yeah, when there's current. When there's current, there's light. Some diodes do that. The ones that do that we call LEDs. Other diodes, and some of you in your starter projects had to use them, they always have a little stripe on one side, so I'll pass the diode that way, and another kind of diode the other way, so you can see to make sure you can see the stripe and try to figure out. And the circuit symbol for a diode, I'll go up here now, looks like this. Big triangle with a bar. Does that make sense? Why does that make sense for a diode?
It only goes in one direction, kind of, but
Yeah, points in the way, and this bar is like, nope, not going to go that way. What's this the circuit symbol for? Resistor. All right. There's another circuit element that I drew in this, what we call a schematic. I'm going to start circling them because sometimes in the circuit, and this is a topic for a different day, what these things are, but they have three elements, three LEDs sticking out of it, and I'll pass it around. It looks like a black half circle, and it's got three wires sticking out of it. What is it? Oh, you've all seen them now in your projects in some way, shape, or form. And in your boards, when you have them in your board, you actually, they're so nice in the board. They draw a little half circle and put three holes, so you know exactly where to put the transistor in. Because